So in the previous session, we have seen the OS and device drivers, how the NIC is getting accessed, the device driver of the NIC. Now in this session, we are going to see the user mod and trying to understand how they work together. So we have seen a bunch of things. We have seen some of the layering of networking. We have not discussed anything in detail, but we have seen the layered nature in the operating system. We have discussed a bit about layering of networking as well in this particular session. So one of the things I would like to highlight here is that most of the things we are discussing here is exactly same in Linux as well as Windows or Mac or any other operating system. Not much difference. All these layers are present in all the operating systems. By the end of the training, you will see exactly how it works in Linux as well. We'll see all these things in Linux. So we are going to do the same diagram in a slightly different way so that we can focus on the right things. So the first thing we are segregating is the kernel and the user. User is where all the applications are running. For example, our client and server. So this is our client and this is our server. Now the other applications which we use to monitor, let's draw that as well. So we had the netstat, then we had the TCP view, then we had resource monitor, process explorer, process monitor, and Wireshark. So this is the user mode. So I'm mentioning it as U here. And this is the kernel mode where the privileged programs are running, including the operating system kernel, drivers, and things around it. Now, what are the main drivers we are concerned in the operating system? They are the AFD.sys, AFD, which implements the socket APIs or provides a file interface for the network subsystem. That is the use of AFD. Then the TCP/IP, TCP/IP.sys. Then NDIS. And finally, our device itself. So this is our loopback virtual device. It is very similar to the Intel NIC card from our discussion perspective. So this is a NIC card, just like the Intel NIC card we have seen. While the implementation is slightly different, we assume that there is a driver for that inside the NDIS, which communicates with this particular virtual device. Where is the OS? So we have drawn our client, server, AFD, TCP, NDIS. Where is your OS? Where is your operating system? Operating system is pretty much everywhere. So for example, there is parts of the operating system running in the user mode along with the client. For example, all those DLLs we've been seeing after Python in the proc mode, we will see that again. That is all part of the operating system, the WinSock library. The WinSock library or the WinSock DLL is the actual DLL or the binary which implements the connect call or send or close, the actual real implementation of the socket along with the AFD. So operating system is everywhere. Operating system is here, 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 here. In fact, NDIS and TCP/IP is nothing but part of the operating system. When you install Windows, TCP/IP, NDIS, AFD, all these things comes up. It's just that they are different drivers. But these things communicate each other via NDOS kernel, which is the operating system. So I'm not drawing operating system specifically. It is there everywhere. In each and every call we will see in procmon, call stack, we will see operating system. Now, what we are interested is the working of the client and server. So purposefully, I'm omitting certain details because some of the gory details are not important for our discussion. There are a couple of other drivers comes into the picture like TDI, NDIS miniport, some other protocol drivers like TCP, etc. We are kind of going to ignore all those details and focus on the client and server. Again, our ultimate goal is very simple: to understand this client and server. These are the two applications we are trying to understand all this while. Now, let's talk about our connect call. That is the first call which is happening from the client to server. Suppose the server is listening and client is connecting. So the connect call comes to AFD. Then AFD in turns connect to TCP/IP. Now it is the TCP/IP which is creating those three packets, the three-way handshake we have seen. So it creates a buffer of SYN packet and send it to the physical layer device, or NDIS in this case. And that NDIS, look at the destination of that packet. The destination is the same computer. It'll give that SYN to this exact same TCP IP in this case, because the source and destination is same in this case. We'll see the source and destination is different. If it was different, that SYN packet would have gone to a different computer altogether. That's the beauty of what we are discussing. In this case, it comes to the exact same TCP IP. It doesn't transfer that packet to AFD because a SYN packet is the business of TCP IP. It doesn't transfer it back to AFD. Now, as part of the handling of the server is also the same system. It'll send a SYN ACK, the second packet in the TCP handshake. That SYN ACK is also returned back to the same TCP IP in this case because it's the same server. If it was a different server, it would have gone to that different server. But in this case, it is the same server. Now, again, it will send an ACK, SYN ACK, and that ACK is also returned. So this is just the three-way handshake we are looking at right here. So this is a SYN on behalf of the client, and that packet is going to the server. So client, server. Server is returning server, client, server. So what that means? So this is coming from the client to the server, and that packet is in turn going to the server, or SYN packet. Then the server is sending SYN ACK, and that is going to the client. Again, the client is sending ACK for that SYN ACK. That is going to the server. So this is important to understand because if the client and server is in different computers, this packet will go to a different computer altogether, will not come back to this exact same driver. In our case, it is coming back to the same driver because our NDIS is having a loopback virtual device. In future, we will see different computers in which these packets right here, let me draw that in a different color. These packets right here, the blue ones, are all going to a different server, going or coming based on the direction of the arrow. Now, what is the role of NDIS here? Right now, the NDIS, or the physical device driver, is not doing much. It is acting as a reflector, but in the real world, this NDIS will connect to the actual NIC card and transfer that data to a different system. That's how it works in real networking. We'll see that. Now, after getting this packet, TCP IP will return back to the AFD, like so. And finally, AFD will connect back to the server or return back to the server. And we get that breakpoint, if you remember when we were debugging, or your accept call will return. What is the information accept is bringing? The details about the client and the client socket. So that is the information TCP IP is giving back to the AFD. Now there is a reason why I have drawn these tools here. I could have drawn anything else. I could have drawn Word or Excel or PowerPoint here because I just wanted to show you any user mode application. The reason I wanted to draw this here is that these tools kind of work with some of these drivers. For example, in the case of netstat kind of take information from, with the help of the operating system of course, from AFD as well as TCP. This is a place where netstat digs its information from. Same with TCP view. TCP view also get the information from these two drivers. All the socket file handle details are with AFD. All the socket states and sender information, the packet information, is inside TCP IP. Same with resource monitor, more or less. They are trying to get information from these drivers. Process Explorer is slightly different. It kinds of take the information from the whole operating system. It has a driver and it enumerates a lot of things from the operating system itself. But ultimately, it'll be querying these information we were looking for from these drivers. Now, Process Monitor is more interesting. Process Monitor takes the information from the bottom layer of TCP. That's why we are able to see those call stacks. We'll have another look at Process Monitor. So Process Monitor kind of take that information from the bottom layer of TCP IP when it is just about to communicate with NDIS to get the packet transferred. That is when it creates something called event tracing for Windows. Doesn't matter to us, but just putting it out there. And how about Wireshark? That is the most interesting part. Wireshark works at the device level. It works inside the NDIS. That's why it's able to capture all those packets. Wireshark is another driver which is connected to NDIS, and it is a packet filter or an NDIS intermediate driver. We'll not get into the details, but all you need to know is the Wireshark is working at the physical layer of the network. Now, talking about layers of network. Apparently, we are right now looking at the 7 OSI layers of the networking stack. We will review it again, but from an operating system perspective, the NDIS or the physical device and its driver comes to the physical layer of the network. So all the hardware and its drivers, which is used for data transfer, is part of the physical layer, or it is also called physical layer. Another layer which comes on top of is called data link layer. In Windows, the data link layer is kind of spread between NDIS and TCP/IP. Data link layer. This is also called MAC layer, where the MAC address is present. We'll get into the details of all this MAC layer. Then on top of the data link layer, we have something called network layer or IP layer. IP or network. On top of that, we have the TCP layer, TCP or UDP. In the example we have seen, it is TCP. UDP is kind of a subset of TCP in terms of concepts. We'll be focusing on TCP. As you have rightly guessed, this is coming from the TCP/IP.sys. But there is a part of the data link layer as well in TCP/IP. Now the OSI defines 3 more layers on top: session, presentation, and application. So these 3 layers are not really present exactly as it is in the modern world networking, while there is a strong presence of all the other layers exactly as it is. These 3 layers are fuzzy in modern day programming or modern day computing or computer networking. For example, in our case, this whole thing was hello world. So all these 3 layers constituted to just one single information, hello world in our case. It was as simple as that. And the server is also sent back to us something very similar to hello world. Now in certain protocol, these things are there, but normally this is very protocol dependent or application dependent. Depends on how you write the software inside client and server. These 3 layers: application, presentation, and session. So we will discuss more about session when we discuss HTTP protocol, which is a protocol which has a typical meaning for session. But not all protocol has meaning. For example, our application has no meaning on a session. Normally, in a combinational way, these 3 layers are called layer 7 in certain terminology or application layer. I have not seen people talking much about presentation layer. It is not really used in the traditional sense these days. But again, depends on how this client and server is written. As a matter of fact, I have seen programs which has more than these layers. They have complicated networking protocol which has kind of more layers on top of this. Certain protocols build layers on top of this, like VPN, which has some kind of recursive layering pattern. Again, doesn't bother us. We are just worried about these bottom layers. In fact, in our training, we'll be focusing a lot on this particular layer, which is the TCP layer, and we'll spend a lot of time on IP layer, routing and things like that. Then we'll try to understand as much as possible on data link layer, but getting into the details of data link layer is not the purpose of this course. But we will get into subnetting, MAC address, how the local routing works inside a subnet, etc. That kind of details. But we'll be spending a lot of time on this 2 layers. Now, before we wind up this particular session, already it is going a little bit longer than normal sessions. If you want, you can take a break, but before we wind up, I want to show you in real world how this things looks, how these drivers and code actually look inside an operating system like Windows. So this is the procmon. We have seen this before, and this is the example of the connect call. We have seen this as well. So if you look, this is like the upside down of the view of things we have seen. So for example, this is our Python application, which is equal to this blue box right here. As I mentioned, it's kind of upside down. The stack is upside down in my diagram and the procmon. So this is that blue box. As you can see, it is part of the user mod. U is here. What is each line inside this thing? They are called stack frames. Nothing but functions, piece of code. This is how program is written. If you are new to programming, this is very common in programming. So this function calls, this function calls, this function calls, this function calls, like that it goes. So function calls one after the other to get something done. So as you can see, the connect is in progress, AFD connect. So at some point, it is switching into the kernel mode right here. The address pattern changes. As you can see, the FF is coming in front. There's a sign it's switching into the kernel mode. As I said, this is all part of the operating system. This is a WinSock library I was talking about, Microsoft WinSock DLL, where all the socket APIs are implemented along with this particular DLL. So this is part of the operating system. This is where the Python ends. And this is part of the operating system which is there in user mode. Basically, this gray shading I have done here, that shading is this and everything in between. Now it is switching to the kernel mode. From here onwards, the privileged mode starts. As you can see, NTOS kernel is there, operating system. Operating system is the one which is communicating with the user mode. There happened an interrupt right here and it switched into the kernel mode, and then OS has handled it to the AFD.sys, which is right here. So AFD is the file interface for TCP/IP, at least from our context. In fact, AFD handles almost all kind of sockets, including bypassing TCP/IP in the case of a raw socket. We don't get into that detail, but AFD is like a file interface for TCP/IP, basically allowing TCP/IP to deal with just the protocol and nothing else. As you can see, AFD.sys is connecting to TCP/IP, and with the help of the operating system. So this again, operating system is coming into the picture to expand the stack, KE expand, stack and call out. So these are all documented APIs. If you want to search in Google, you can search. You will get to know what all these things are doing if you want to get into the details. But these functions are not documented. I don't know any documentation around TCP/IP. I will show you some of the things shortly, what is documented, if you want to read more about what we are talking. Now TCP/IP doing all kind of things to get the connect packet working. Again, calling into the operating system to expand the stack, and ultimately it is calling into the event tracing for Windows right here. This is how procmon is tracing this event, this call stack from the operating system. Now, although procmon is only able to capture till here, next level on the top, if it was there, the NDIS would have come. In one of the version of the training, I was showing a breakpoint in a kernel debugger in the npcap driver of Wireshark. In that, you can see the NDIS stack as well in the kernel debugger. But in this case, we are not going to that kind of details because it's not a driver development training for Windows networking stack. We are just trying to understand how networking works. So on top of this, it was supposed to be the NDIS should have come. And inside NDIS, we should have seen the loopback driver comes into the picture for the loopback device, virtual device, which must be doing something very simple like a mem copy to implement this part of the diagram. Now, let's look at Process Explorer once again to see some of these drivers we are talking about. So when you do this experiment, if you're doing it yourself, not compulsory again, right click, run as administrator, because we are going to look into the kernel with the Process Explorer. If you don't have admin rights, Process Explorer won't be able to load a particular driver to see everything. So Process Explorer has started. In this case, what we are interested in is the kernel itself, which is a process called system. This is the way it shows the kernel application. Everything with that K in front, which is the privileged mode. As you can see, the guy is here, the NT-OS kernel. All the drivers you will see here. These are different threads inside the kernel. As you can see, our NDIS is here as well. Probably not doing what we are expecting it to do. Mostly it'll be doing something related to some of the packets handling which is going on inside this laptop right now. Not really anything to do with our applications. But feel free to click on it and see what you want. But what I wanted to show you is the DLLs. So here we have the AFD.sys, which implements the WinSock, as you can see here. And then let's see the TCP/IP protocol driver, TCP/IP driver. It's a very stable driver in Windows. I have not seen much of a crash from this driver in a long time. And let's see our NDIS. This is our NDIS, which is the wrapper driver for most of the network interface devices. So this is a live view of this laptop right now. You are looking at the network layers of this laptop right now where I'm doing this presentation. These drivers are always loaded into the operating system by default, whether you are running the application or not. In fact, our applications are not running right now. It is not being debugged. So this is the driver of Wireshark or npcap. So this is a binary which connects to NDIS and copy the packets for Wireshark to see. The hello world came inside Wireshark, which means that Wireshark somehow intercepted our client and server. So this is the driver we are talking about, npcap, where the Wireshark is getting the data from. So it is hooking into the NDIS. It is an NDIS intermediate driver. That is this particular driver. As you can see, it is maintained by insecure.com. And it is not a Microsoft driver. It's a kernel filter driver. It is open source. You can look at the code of npcap if you want to read more about it or understand more about it. So one final thing I would like to show you is the documentation of some of the things we have discussed. So while we were talking a little bit concrete about Windows, almost everything we discussed is true for Linux or any other operating system as well. There'll be a module to handle the file objects, which is coming from the sockets. There'll be a module to handle the TCP/IP protocol because it's a very complicated protocol. A person who is dealing with file handles doesn't have to deal with TCP/IP in general. And of course, there'll be device driver stack for the NIC card, which doesn't know anything about TCP/IP. So all those are different software development problems. So it is common to all platforms what we discussed. It's just that the NDIS will not be called NDIS. It will be called something other names. Some other name it will be called. But there will be a driver. There will be a kernel module which does the task. So you can search for Windows networking architecture and OSI model. It explains some of the things we discussed: the application, presentation, session, transport network, data link, and physical layer. Again, like I mentioned, these 3 layers, take it with a pinch of salt. It is not what it is as most documentation says. In our application, these 3 things combine to form just hello world. Remember that. All these 3 layers. Everything is just one hello world. We had the other layers. In fact, we didn't have much of a data link and physical layer, but soon we will have when we connect to a different computer. The same program, we are going to put it in a different computer and access using proper IP addresses. Then we will discuss about all those details. So physical layer, nothing but the NIC and the drivers. Data link layer is the MAC address and things like that. We'll see that. It is implemented kind of between the NDIS and TCP/IP. Network layer and transport layer implemented in TCP/IP. You can read in detail. In Windows terminology, it is called protocol drivers. Protocol drivers are drivers which interacts with NDIS drivers. Read and write from NDIS. They are also called transport driver or transport layer driver. It's all just different terminologies. So in this document, it says data link layer is divided into MAC and LLC. LLC is in the protocol driver, which is TCP/IP in this case, and MAC layer is part of NDIS. So this is the overview of NDIS, which is a physical layer. Again, you can read if you like more details. Filter drivers. NDIS filter drivers is the one we looked at, the Wireshark filter driver. It'll give all the packets going through NDIS, packet filters or packet sniffers, packet capturing tools. In Linux, it is TCP dump, the Wireshark equivalent. So I have downloaded this PDF and added to the training. So you will be able to download this particular PDF if you want to read about it more, but I don't recommend going into too much of details. It's all about driver development in Windows. Most of the things are very Windows specific, but remember all the concepts are very generic. Now, so far we have been seeing a loopback. We've been using an interface called loopback interface. Now it is time for us to use multi-system. So we are going to communicate between systems. Our programs are not going to change much, but only the loopback interface is going to change. Let's see how that is done in the next lesson.